If you consider the area of a triangle to be just a series of straight lines that you're adding together, let's say a pile of paper, you have your layers of paper all stacked together, but then the paper gets smaller and smaller. So then eventually the sheet of paper at the very top is very, very thin. The total amount of paper wouldn't change if you shifted it. If you shifted, let's say some wind came through here and blew the paper to one side and blew it so that it was like that up against a wall, you've still got the same amount of paper there, but it's just blown across a little bit. And we're going to make this a 90-degree angle. So that there is 90 degrees. We know that the base is 5 centimeters and the height is still 4.2. That hasn't changed. And the area of this thing is just half of the rectangle that you would make like that. So the area for this triangle is 5 times 4.2, but then divided by 2. And that would be the same however this triangle is oriented. Even in part B, when it blows a little further than 90 degrees, the formula is still going to be the base times the height divided by 2. And it's the same for any triangle, but the one thing you have to be careful about is the height has to be perpendicular to your base. If, for example, the question was like this, and it said that was 5, but this length here was, let's say, 6, and that length there would be 5. This 6 is actually irrelevant. We wouldn't use that number at all, because this isn't the perpendicular height. So sometimes if it give you this length, for example, that's 10, you would ignore that one as well. These are the only two values that you're going to consider. It's the base of the triangle and the perpendicular height of it. And the formula is a half of the base times the height. You could write this, of course, as base times height, all divided by 2. So that is the same formula. If you just did a half before, or times by a half at the end, or multiply by a half halfway through, it doesn't actually matter, as long as you didn't multiply the half only once. Okay, in the next example, it's asking us to find the perimeter and the area. So we have to find two things here. Let's do the perimeter in red. So the perimeter is the length around the outside. So if I just start here and walk around the outside of this thing, all the way around to the beginning point, that total length is the perimeter. Peri actually means outside, and meter is a measure, so it's the measurement of the outside. Let's walk around here anti-clockwise. So it's going to be 6 plus, and this length here, it appears to be 8. So we'd have 8, and then we'd walk up a little bit well, the total length here is 6. That length is 1. That length is 4. That's a total of 5. This length here would be 1 as well. We'd add the 4, add this 4, add this 4, add the 1, and add the final 8. Now this is actually quite a big sum, and it's actually a shortcut, because if we wanted to walk from here to here and across here again, that's the equivalent distance of walking from here in this route instead. And we can do the same thing here. So to walk from here to here, we could alternatively walk up and around, and then the total perimeter is actually that of a rectangle, where it's 6 down and it's 8 and 4, so that whole length there is 12 to here. And so a quicker way of doing the perimeter would be 2 6 plus 12s. This is just a quicker way of working out the perimeter of a shape like this.